See, now we're discussing about the topic is meter bridge. See, the meter bridge is a practical application of Weinstein bridge. The practical application of Weinstein bridge. Now the practically how to we can the derive of this Weinstein bridge. See here the first aim. See what is the aim? To determine unknown resistance of wire. Which we can find out here the unknown resistance of the wire. Next principle. It works on the principle of Weinstein bridge. It works on the principle of Weinstein bridge. So what is the formula is that P by Q is equal to R by S. The next we're discussing about of a construction. The construction means the how to construct of the meter bridge and how to we can find out the verifying of this Weinstein bridge. Now we're discussing about the construction. The construction is nothing but the how to the construct of this meter bridge, and now how to we can find out this the principle of the Weinstein bridge the using by this. See, let us now we consider here the two L-shaped copper strips. What do we consider this? Two L-shaped copper strips. So this is the first copper strip, and this is considered the another copper strip. So this will be have the two L-shaped copper strips. Now we can write here the copper strip. See, these are two L-shaped. We are consider this as a M. This is denoted by the M, and it is denoted by the N. Now this two L-shaped copper strip between we taken by the another one of a copper plate is introducing by the this is the between, and now here can be form of a two gaps. How many gaps are can be formed by this? The two gaps are can be formed. See, one is say the here the one gap is say the G1 gap, another one gap is say the G2 gap. See, this is the two gaps is there. This is G1 and this is considered G2, and also is called the left gap, and this is also is called the right gap. See, one is the left gap, another one is the right gap, and this the two L-shaped copper strips is between is connected by a manganese wire. What is connected by is the manganese wire is connected by this is the manganese wire. Manganese wire is connected by the points between the A and B. What is the points there? The A and B between is connected by the manganese wire. This manganese wire, the parallel to we are connected by the 1 meter scale. See, this is the 1 meter scale is connected parallel to the manganese wire. This is the parallel meter scale. This is the readings are there. The meter scale means how many centimeters are there here? The 100 centimeters. Now this is the meter scale. Meter scale is attached parallel to the manganese wire. Now here, this is the which is the left gap. In left gap, we are connected by the which is find out the resistance that will be connected in a left gap. That is the unknown resistance of the wire. Unknown resistance of the wire is connected in a left gap. See, this is the unknown resistance. Unknown resistance or unknown wire is connected in a left gap. In the right gap, we can find out the which is known. That means the resistance box. The resistance box is introducing between the right gap. This is the resistance box. RB is nothing but the resistance box. Now it's center at the point. This is considered the C point. What is considered? The C point is the plate. Now this C point is connected, which is connected by there is a high resistance box. See, that is the HR. High resistance box is connected by the between the center of the C point. And this is acrosses. It is acrosses. We are connected by a galvanometer. What is connected by the galvanometer is connected by there. See, the galvanometer is a very sensitive. Then the high current can be passing through this galvanometer. It can be damaged. That means it will be protected. The galvanometer can be protected. The before we can using the high resistance box. The high resistance can be the reducing of the current, and it is across this galvanometer is across we are connected by the jockey of the J. What is connected by the jockey J is connected by the jockey J is connected by now this points. What is the manganing wire of the points A and B? The between we are connected by a battery of EMF. See, this is the battery of EMF, positive and negative EMF. E is connected by there, and it is across we connected by the plug key K, and is connected to the B point. This total construction is called as the meter bridge. This total construction is called the meter bridge. Now this total connection is completed. Now it's a right or wrong. It's a verification is there. Now when this jockey is pressed at the left side is nothing but A point. Now the galvanometer shows the reading at the right side. For example, the jockey can be pressing at the B point, then nothing but is the right side. Then the galvanometer shows the deflection is in a left side. See, in galvanometer, that is a reading side. This is the galvanometer. Now the center point is there, the 0. Now it have the right side reading and left side also readings, just like of a voltmeter. Now here is there that this is the pointer. What is this in a pointer? See, when the jockey is pressing at the left side, the pointer showing a right side. When this jockey can be pressing at the B point, it's showing a left side. That time this total connections will be correct. After that we can start its experiment. Now the experiment we can start. The jockey is pressing of the various of the point. At the start at the A point, because of when the plug can be closed. When the plug can be closed, the current can be passing through in the battery of EMF I2. The current can be passing. This is the direction. Now, see, why are we using of here the manganing wire? The manganing wire is a high resistivity, and low temperature is constrained by there. High resistivity and low temperature is constrained. That's why we can using of the manganing wire. When the current can be passing through this one, there is no damage of this manganing wire. Now we're discussing about the procedure of this meter bridge.